Alright, so in this video, we're going to go over how to solve the system of inequalities using our calculators. For the question, y is less than or equal to negative 3x squared minus 2x plus 3, and y is greater than 3x squared minus 2x minus 2, we are going to find the solution of this inequality that is the same for both of them. Alright, so now that we have our system of inequalities, what we want to do is we want to change the inequalities to an equation with an equal sign. The reason why we want to do that is easier to graph that way, see exactly what we have with the two different quadratics, and to find its intersection points. So we want to go into y equals, and I already put the two functions that we have into our y equals. Again, they must be in standard form. And then we want to graph our functions. So there's the graph of our functions. It's a little hard to tell exactly what's going on, so we want to go into zoom standard. We want to make sure there's zoom standard, and we'll go from there. So zoom standard 6, so we go down, we press enter again, and that's a little better. We can see that there's two intersection points, one is there and one is there. And now what do we want to do? Well, we want to go into second trace. And what second trace is going to do is we can go into intersection. And we're going to have to do this twice since there's 2 points of intersection. You press enter and you see what it says. It says the first curve. So we're going to go close, not all the way close, but close to this intersection point right here of curve 1. We're going to press enter. And then we're going to go to the second curve close to that point, but not touching it, and press enter. It's going to say guess. We press it again. And we can see that one intersection point is at x equals negative 0.913 and y equals 2.32, and we'll go one more decimal point, 6. So there's one intersection point. The other intersection point, we have to do the same thing, but we want to go closer to that point now. So second trace. Again, we go into intersect. We press enter. It's going to say curve 1. We now go to the other side of the parabola, close to the second intersection point. We press enter. It's going to be on the second curve. So we go to the intersection point. We press enter. It says guess. We press enter again. And we see the second intersection point is at x equals 0.913 and y is negative 1.326. So now we have our 2 points of intersection. So now what do we want to do from there? Well, we want to go back now to our y equals. So we're going to go back to y equals, make sure it's y equals, good. And now we're going to, instead of making these equations, we're going to make them inequalities. And how we do that is we move our pointer over to the left until we are right here. And the first inequality was less than or equal to. So less than or equal to, we press enter until we reach the less than sign. And the less than sign is right there, that triangle that's on the lower right angle triangle. All right, we press enter. Oh, sorry. We keep it there. Let me go back to it. Okay, there we go. That lower right angle triangle. We then move back over and down, and we want to go into our next inequality. We go over to the left. And this inequality was y was greater than 3x squared minus 2x minus 2. So we press enter until we get to the right triangle, but that right triangle, the upper right triangle, means greater than. Okay, we move back over to the right, and now everything is set. We press graph, and now we see our shading. So in the shading, we can see that this triangle, this quadratic up here, everything was shaded inside the quadratic, inside that U-shaped parabola. In this parabola, everything was shaded again inside that parabola, but that's a frowny face parabola, so everything was shaded inside. And when we look at the intersection point, that is our solution, where the shading of one parabola overlaps the shading of the other parabola. And we can see that that is between the points of, we found before, negative 0.913 in the x, and the y was 2.32, which is right here between that point and our other intersection point, which is here. X equals 0.913 and y equals negative 1.326. All right, so on the test, what you're going to have to do is you're going to have to sketch this very quickly onto your plot, and then I want you to show me the solution shaded. All right, so now that we wrote down our intersection points, we will now take the graph from our calculator and draw it on either our test, our booklet. So where do we begin? Well, the first thing I did was I color coordinated the different quadratics. We have one quadratic which is red and one quadratic which is green. And we're going to start with the red quadratic. Now this is where most people get into trouble because they forget their rules of inequalities. When you have an inequality that is a less than or equal to or greater than or equal to, we have to remember that the parabola must have a solid line because we're including the points on that line. So for the first quadratic, the y is less than or equal to negative 3x squared minus 2x plus 3, I will draw a quadratic. We know it's a frowny face quadratic, and it's going to have a solid line. So it'll look like this. Again, this is just a rough sketch. We have to be in the ballpark of what these quadratics will look like, and we're using our calculators to guide us. The next quadratic, we're going to make a green quadratic. And this quadratic is of the y is greater than 3x squared minus 2x minus 2. And this quadratic, we see it's a greater than sign. So we know with greater than or less than that the line has to be dotted because we're not including the points of the quadratic. So I will draw that line, that quadratic as a dotted line that looks something like this. All right, that's what our two quadratics look like. And now what I'm going to do is I'm going to shade exactly what the calculator told us to shade. Again, if we don't want to rely on the calculator, we can always choose test points to see which of our statements are true, and if they're true, then we shade. So what I'll do is I'll shade the red parabola first, and we know that shading is inside the parabola. So I'll just get my marker out, I'll bring down my opacity, and I'll make a nice shade inside of our parabola, like so. This is exactly what was shown to us on our calculators, so we want to make sure that we show it graphically on our test. The next thing I'm going to do is I'm going to do the same thing, but now this time I'm going to do it for the green parabola. And we saw, according to our calculators, that the shading should be inside this parabola as well. So I'm going to depict that right now, like so. So on the test, we're showing what our inequalities are saying about our quadratics, like so. Now, where is the solution? Well, the solution is where the overlapping of the shading takes place. So we can see, I'll make it in a different color, I'll make it in blue. This is our solution right here. That's our solution that I'm coloring in right now. Okay, there's our solution. And what I'll also do is I'm going to put our intersection point. So we have an intersection point right there, and we have an intersection point right there. And that intersection point I'll draw is to this, and this intersection point goes to this, like so. So now everything is graphically represented. We have two parabolas with the correct shading according to their inequality symbols, and we have a solution which is shaded, and we have our two intersection points where those two quadratics intersect, where the point where they both equal each other. So on the test, this is exactly what I'm looking for. We have to make sure we can input it into our calculator properly. We have to make sure that we're able to find the intersection points by using our second trace intersect. We have to perform that operation 2 times. We then have to take our graph and we have to sketch it on our test booklet, making sure that we remember that the quadratic lines have to coincide with what symbol we have, what inequality symbol we have. Do we have a greater than or less than, which is a dotted line, or do we have a greater than and equal to or less than and equal to, which is a solid line? After we do that, we make sure our shading of the solution is correct, and that's about it. Hopefully this video has helped you learn how to input everything into your calculator, find out what the solution for the system of the quadratic of inequalities are, and we'll be able to get you at least 20 points on tomorrow's test.